thank you for agreeing to join the Harbor Watch, River Watch volunteer teams monitoring the health of our rivers in Fairfield County. The work we do is critical in establishing scientific baselines for biological and environmental data so that policymakers can make the best decisions and identify potential problems that need fixing. The work is technical, but can easily be learned even by someone with virtually no scientific background or training. After watching this video, you'll have seen exactly what you need to do, and once in the field with the accompanying step-by-step handouts, you will quickly become comfortable and grow into a valuable team member. I'm Pete Ferboni, Associate Director and Quality Control Officer at EarthPlace, and I've been training volunteers in water quality monitoring for over 20 years. Sit back and get comfortable while we show you how water quality monitoring is done. Today's video will demonstrate our procedures for 3 separate stages of water quality monitoring day. Assembling the needed gear in the lab, performing and recording various measurements in the field, and wrapping up your work back in the lab. Let's start in the lab. Here we will select metering equipment and make sure it's ready to go. Assemble all the sample bottles needed for your sites and pack them in a cooler. And fill out the initial portions of the field record sheet. The first piece of equipment you'll need is the dissolved oxygen meter, usually referred to by its initials, the DO meter. Here are several in the lab, each with a wooden carrying tray or box for holding smaller pieces of gear. If the river includes monitoring sites on bridges, choose a DO meter with an extra long cord so you don't have to climb down the bank to get a reading. Next, you'll want to check the probe for air bubbles under the membrane. Large air bubbles prevent the meter from working properly, and if not caught in time, cause your DO data to become inaccurate. Begin by removing the protective plastic covering from the end of the probe and observing the fluid electrolyte under the acetate membrane. It may be helpful to gently depress the pressure compensating membrane, the rubber disc, on the side of the probe a few times with the eraser end of a pencil. If air bubbles are present in the reservoir below the membrane, they usually rise to the underside of the surface of the membrane and become visible. If there are many air bubbles, a staff member will need to change the membrane and add electrolyte, which is potassium chloride solution. Just alert one of the staff members about the problem so we can take care of it and select another meter to take out for today's work. Once you've confirmed that the probe is in good shape, turn the DO meter on so it will have time to warm up before reaching your first sampling site. Turn the dial to the right to the first stop labeled O2 temperature. The DO meter remains on until all sites are measured and is only turned off when the calibration is checked after all sites have been tested. Make sure DO meter carrying tray contains a thermometer for air temperature measurements, a pen for recording field data, a squirt water bottle with distilled water for rinsing probes after each sampling event, and a strong cord for lowering sample bottles from bridges. Distilled water bottles are located on the sink counter if they are not included with the DO meter carrying boxes. If you need to add water to the wash bottles, the distilled water reservoir container is located over the sink. The second meter you'll need is the salinity conductivity temperature meter, model 30, usually just called the conductivity meter. These are usually stored on the shelf in the hall. Turn the meter on to check if the mode is set correctly. It should be set to the specific conductivity mode, and you'll know it's in the correct mode if you see the small centigrade symbol flashing in the lower right corner of the screen. If the setting is incorrect, simply toggle the mode button until you see the flashing symbol. Now that you'll get a data record sheet and clipboard and begin filling it out, starting with the name of the river or stream you are monitoring, the date, the names of the people on your team, the weather today and yesterday if known. Today we'll be filling out the sheet for the sites on the Aspetuck River, but the process is the same for all rivers and streams. Next, you'll fill in the sampling sites that you'll be monitoring in the boxes in the station row. Remember to repeat one of the sampling sites. This site will be where a DO and conductivity will be measured a second time, and a second separate sample will be taken. This site is known as the duplicate site. Place the clipboard with the data record sheet in the DO meter carrying tray to record data from the field. Now you need to gather the number of sterile sample bottles with aluminum dust covers that will be needed for the sampling event. There should be one sterile bottle and plastic bottle with aluminum dust cover for duplicate site that we talked about previously. One sterile glass bottle, which we've marked the FTB, for field tramp blank, and an extra bottle just in case one gets broken in the field. Sterile sample bottles, both glass and plastic, are stored on the shelf rack above the DO meters. Often these sample bottles will be labeled prior to your arrival to the lab by a Harbor Watch, River Watch staff or volunteer member, and will be on the lab bench ready to go. If the sample bottles are not labeled, label them with a felt tip marker pen. Mark the site numbers on the tops of each bottle. Don't forget to label dupe on the duplicate site bottle and mark FTB on the top of the field trip blank bottle. Put all sample bottles into a cooler. Remember to include a bottle of sterile dilution water, also called buffer, from the refrigerator. This sample will be transferred in the field into the sample bottle that is labeled FTB. Also place a plastic bottle labeled temperature blank found in the refrigerator into the cooler along with the sample bottles. Ice the cooler down by putting several ice packs and ice cubes from the freezer around the bottles in the cooler. Finally, take a calibration wand and grabber with you for your team. You're ready to pack up the car and head into the field. Now that you're actually in the field, you need to learn 3 separate routines for successful data collection. Calibrating the DO meter at the initial test site, performing the various measurements and recording them correctly on the data record sheet, which we do for every site, and checking the DO meter calibration at the final testing site. Upon arrival at the first sampling site, put the correct sampling bottle in the DO meter tray. Then take both field meters, the clipboard with the data record sheet, the grabber, and the calibration wand to the spot where you'll be collecting your first sample. Record the time of arrival on the data record sheet in the appropriate box. If possible, hang the air thermometer on the nearby shrub or tree to equilibrate it to the air temperature before taking a reading. This usually is about 5 minutes. The DO meter will need to be calibrated before taking measurements, but the conductivity meter is ready to go and needs no calibration because that's already been done in the laboratory by the staff. Place the calibration wand, DO probe, and conductivity probe into the water. Remember to turn the SCT meter on. After the calibration wand has been sufficient time to be cooled to the water temperature, and this usually takes about 5 to 7 minutes, take the wand out of the water and pour out the water from the calibration chamber. After doing that, place the probe into the moist chamber. The probe now is in a humidified chamber, more closely attuned to the ambient water temperature that will be tested. Allow about 2 minutes for the probe to equilibrate in the wand. Turn the meter knob to the calibration step on the dial. Press the confirm button when asked to calibrate to the percent, and then press the confirm button again when prompted when the percent is 100%. The meter then goes into the calibration mode. The meter then beeps twice after the calibration is complete. Turn the dial back one stop to the O2 temperature stop and observe the percent display in the lower left of the digital display. The percent should remain fairly stable at 100%, and if so, the probe can be removed from the wand and is ready to go. Once the DO meter is successfully calibrated, it can now be used for taking measurements for the entire run. If the reading wanders away from the 100% setting, the calibration process needs to be done again. Possible problems such as water leakage into the chamber during the probe calibration may have occurred, or an instrument may have not been properly warmed up. These problems can cause a faulty calibration. At each site, we collect one water sample and take 5 readings: dissolved oxygen, conductivity, water temperature twice, 1 reading from each meter, and ambient air temperature. To take a dissolved oxygen measurement, place the probe gently into the flowing water. If there is little current, it is helpful to swirl the probe in the water to get a stable and accurate reading. The reason for doing this is that the DO probe consumes oxygen as it measures it. Read the DO reading in milligrams per liter found in the upper left corner of the meter's digital display, and record the reading on the record data sheet in the DO box in the column for that labeled site. DO meter will give water temperature in the upper right corner of the digital display as well. Record that reading in the upper water temperature box. Next, we'll take the conductivity reading and the second water temperature reading. Place the conductivity probe in the water. Usually you do this at the same time as you've done with a dissolved oxygen meter probe. And read the conductivity in microsiemens off the meter, and record that measurement in the conductivity box for that sampling site. Make sure the meter is in the specific conductance mode. Again, this is signified by the blinking centigrade symbol. The conductivity meter also measures water temperature, and that reading is placed in the lower water temperature box. Usually this reading is the same or fairly close to that of the DO meter. After measurements are taken, retrieve the probes from the water, wash off both probes with DI water, and carefully wind up the probe cords. The conductivity meter should be turned off after each sampling event to save batteries. The DO meter, however, must remain on until all sites are tested and the calibration is checked after the last site is measured. Now use the grabber to take a water sample from the sampling site. First, you'll need to take out the stopper from the sample bottle. Sometimes these are a bit sticky and you may need to gently tap to loosen it. With the grabber, place the bottle away from the shore with the mouth upstream and plunge the sample bottle under the water. You want to leave the bottle under the water for a few seconds to dispel the air. Do not get the bottleneck in the sediment or on the bottom of the stream. Retrieve the filled bottle from the water, usually a second person is helpful here, and pour out the water in order to leave a headspace, which is the empty area at the top of the bottle. This headspace is needed during the shaking of the sample prior to membrane filtration of that sample. Shaking the sample will resuspend any bacteria that have settled to the bottom of the sample bottle. The goal is to disperse the bacteria evenly throughout the sample bottle prior to removing a sample for filtration. If gathering a sample from a bridge, Use a strong cord provided in the DO box and attach it securely to the neck of the sample bottle. Lower the bottle on the cord and plunge it into the water several times and leave it there. Leave it under the water for a few seconds and gently retrieve it. Again, pour off some water to leave a headspace. Finally, you need to read the air temperature from the thermometer and record it on the data record sheet. Shaking down the thermometer may be necessary, but be careful not to break it. After the thermometer is calibrated, record the ambient air temperature measurement in the appropriate site box. Now you're ready to pack up and move to the next site. Back at your car, you should immediately place the filled sample bottle in the cooler and pull out the correct bottle for the next site. The sample collection and measurement routine is the same at all sampling sites, with one exception. At the duplicate site, simply repeat the DO and conductivity field trips. After the first measurements are taken, remove the probes from the water and repeat the measurements again. Record that data in the duplicate sample column. The duplicate site is also a good place to take care of the field trip blank procedure. Take the sterile buffer that was in the cooler and transfer it to the sample bottle labeled FTB. Put that sample bottle into the cooler. This is a simple check to make sure that the sterile sample bottles haven't been compromised in the field. At the last sampling site, take the calibration wand to the site and place it in the water while you collect your field data and water sample. After all measurements are taken, pour out the water from the calibration wand and place the DO probe into it, sealing it with the rubber stopper as before. Remember, return the wand back into the water. Check the percent saturation. It should be within 95% and 105% range. Record that value on the data field sheet in the space provided. When you completed your last site, all that remains is to head back to Earthplace and check in. There are just 3 tasks to be done. Take the final reading and make sure the data sheet is fully filled out. Hand over the collected samples and data sheet to one of the staff and return the meters and other equipment to their storage places. The last reading you need is to record the temperature of the temperature blank. Blank bottle that is placed in the cooler before going out. Take a lab thermometer from the thermometer rack located near the entrance to the lab and place the thermometer into the temperature blank bottle and read the temperature after a minute. Record that temperature reading on the data record sheet in the space provided. Remember to record the time of arrival to the lab in the upper right of the field record sheet and the date of sampling. Fill in the name of the staff member who takes the samples in the space labeled Received By. Put the meters, grabber, and calibration wand back where they belong, and you're done. We've covered a lot today, so it may be helpful to quickly review in the lab. In the lab, before you go out, you want to select metering equipment and make sure they're ready to go. Assemble all the sampling bottles needed for your sites and pack them in a cooler. Fill out the initial portions of your field data sheet. Once in the field, you'll need to calibrate the DO meter at the first site and check it again at the last site. At each site, you'll collect 1 water sample and take 5 readings: dissolved oxygen, conductivity, water temperature twice, ambient air temperature. At one site, you'll repeat the dissolved oxygen and conductivity readings, and you'll transfer a buffer from its original bottle into the field trip blank. Finally, back in the lab, you'll make sure the field data sheet is complete. Hand over the samples and data to the staff and put away your equipment. On behalf of Earthplace, I'd like to thank you again for volunteering. It's hard to overstate how important your contribution is to our work. For without you and others like you, we simply wouldn't be effective as we are. Harbor Watch River Watch has been monitoring the health of our harbors and rivers for over 20 years, providing data to policymakers and regulatory bodies at the federal, state, and local levels. They trust us not just because they know we're passionate about the environment, but because they know we're careful and follow the rules of scientific procedure. I'm sure you'll make a great addition to our team, and all of us here at Earthplace look forward to working with you. Thanks again for joining us. There's a lot of work to be done.